Hi everyone. We're now into materials, so we'll be discussing on wood. Basically, we'll just give you a quick run through on how the slides are prepared. So what is utilized or what is discussed as we are progressing to materials construction. So for now, we just have a few keywords to remember when describing wood. So wood is has a rich texture. It has a variety of materials, finishes, and applications. The thing with wood, it's really associated with the word or keyword warmth, and it's also cost efficient. As designers, you have to be more knowledgeable as to where we far if the woods that we are getting or the materials that we are getting is sustainable. That's why you have your regulations with regards to what kind of wood that is being utilized in the market. Okay, so for the wood, so you have the strength and the durability. So given it is a long lasting material, it is perfect for any application when it comes to interiors, let it be for construction, for structural, or even interior finishes and your furniture. So with wood, so you can see that there's a general warmth when you look in wood, and it also adds a bit of a natural element into any space. So with wood, you have these range of tones that you can utilize in any application. For me, as a designer, I usually take in the materiality of wood as it is. I like it in its in its natural state, and I hope you guys would be able to have a wide range of or like a wide vocabulary of the different applications and the different materials in wood or the material applications of wood. Okay, so you can it's in the presentation, so I'm just giving you a quick run through on how to approach the readings. So you have with wood. So if you if you research, there's a lot of, let's say, debates if whether on how sustainable the wood would be. So I think now we have your farmed woods. So these are woods that are actually grown for the purpose of construction or the purpose of production. So with wood, it's a renewable, but it depends. So there's a very large gray area uh, as to the sustainability of wood. So you have your endangered species or those endemic. So those are who are um, those wood that would really take a long time to grow. So we want to steer away from that and go for a more sustainable approach when it comes to material selection. So given with the wood, you just have to go for more sustainably sourced or those farm woods whenever you're whenever likely to use them in furniture or your finishings. I think nowadays there are a lot of wood composites or byproducts of wood or even wood alternatives that would come as sustainable than just chopping off those like 50-year-old or 100-year-old trees. So as much as possible, even in the Philippines, this is very prominent or that really happens up to this day with regards to the illegal logging down in Luzon, Visayas, and Mindanao. But I hope that um, that as designers, as upcoming designers, we make conscious decisions when it comes to material specification. So I think with regards to sustainability, I think it's safe to say that we go for trees that are fast growing or we have alternatives to go about that. So you have your bamboo, your jamelina, which would take around 7 years to grow, or for those woods, yes, it would actually take longer for a wood to grow. So you have to be mindful as to how we utilize them and how we want to maximize them. So for wood, so you have a lot of variety when it comes to the materials and finishes. So you have your aged wood, your antique wood, your wood that would come off like driftwood or weathered wood. So there is a vast selection as to what design direction or what design direction or concept that you're trying to develop. Okay, so the versatility with wood. So um, unlike any materials, there is a whole range of applications with wood. It would actually go well with any material finish, whether it be metal, stone, um, fabric, soft fabrics, leather. So I think wood, with regards to versatility, is very flexible. So you have a variety of shades, range, grains when it comes to wood would actually be fitting in any design concept or even into developments with materiality. So you can paint it, you can stain it, you can keep it natural or anything that's possible with wood. So with wood also you have um other woods have greater weatherability compared to the other woods, which actually seep in more water. So you have to be conscious when it comes to the design application, whether it be indoors, outdoors, or structural. Okay, so for the benefits of wood, so we'll just discussing it in a fast pace. So for the benefits of wood, so it is a renewable and a recyclable material. So unlike plastic, wood can be utilized. It can be developed into a composite, or it can be recycled to come up with this oriental stranded boards or your um, your your composite boards that is used for cabinetry. So um so compared to let's say plastic, when you throw it out in the landfill, there is less chances of it to be, let's say, to decompose over time. And then when it does decompose, it's actually very dangerous to the environment, also to human health. So for wood, so wood is a carbon positive, or that has a carbon positive benefit. So timber is a greenhouse positive product with a lower net environmental impact than those other building materials. So basically, it doesn't give off excess carbon emissions, and then it is more sustainable once these if we have local farmers who do replant these trees, who are those who make ways to make it more sustainable or long term. So we don't want to get supply from people who just cut, let's say, from forest or from, yeah, for protective forest or for any of the like. So that's what's happening in Brazil or Amazon, even here in the Philippines. So you have your Mindanao with the illegal logging. So you have to consider that into how the material has been processed and then delivered to you. Okay, so for the wood, so there is a low energy production, so it doesn't take up so much of the world's resources to produce. It doesn't give off that much of a pollutant once you process it. So basically, there is less volume of water or volume of any resource electricity to run through or to produce the wood. Okay. So for wood, so health and well-being. So given that wood is derives from nature, um so it actually it actually connects us or gives us the valuable feeling of being with nature. So as described here, so wood, or even the presence of wood or natural materials, have increases your emotional state or improve your emotional state. It actually also improves the air quality, and then gives you the feeling of warmth and comfort, and it actually lowers blood pressure. I think the environment of being surrounded with wood, say as even with plants, will have these health benefits later on. So for wood, Um, Wood is still a combustible material, but it burns in a slow, predictable, and measurable way. So we have um, we have wood that would actually we have, let's say, a process in wood that, let's say, the charcoaling of the wood would insulate the inner core from, let's say, getting burnt. So some other, like, there are different kinds of wood that would actually resist more, so it depends on the material makeup of the wood, or its its genetical makeup. So you have to consider that. While for those wood who lack that natural characteristic, you have different applications for fire resistance later on. So I will discuss it to you promptly. So okay, for wood, so wood or timber has a natural insulating material that creates a barrier between heat and cold. So I think this is very prominent when, or it's very let's say, comes out like when you look into more log cabins. So there is a natural insulation when it comes to the wood. So that's why you have your whole wood cabins, your log cabins, and everything, and even in the middle of a cold. So for this, you also have your electrical properties. So, wood has a resistance to electric current. So, a completely dried wood is equal to that of phenol formaldehyde. So, okay, so you have different properties. So, won't actually transmit um, electricity through the material. So, given that static electricity is dangerous for human health. So that this is very visible, this is very noticeable when you have an exposure to metal or plastic and other materials. So therefore, so therefore we conclude that wood is a healthy material. Okay, so wood is also known for its mechanical properties. So wood, given has different strengths depending on the material or depending on the construction. So as you can see, you have your wood has a tensile strength. So I think this is, you can see this in, let's make for example the airport. So they use wood as the arcs. So with a tensile strength of it, that would actually encompass the whole vast structure. So you can see how the construction is made, how with the support of metal, additional support of the metal would come up with that wide, vast architectural feature. So for wood, so you have your aesthetic properties of wood. So wood is a decorative material. So you can carve, you can etch, you can bore holes in it. So it has it's very versatile when it comes to um applications. So whether you want it thinly sliced like the veneers, or you want it thick, that would be serve as your structural. You want it to be curved, it's easy to manipulate the wood, given the technology. Even even with the use of your hands, you can manipulate wood into what shape that you want. Okay, so wood also has oxidation properties. So metals get rust, wood doesn't. So for such characteristic, the use of wood is to avoid rust when necessary. So let's say when you are experience, or you're given a chance to design, let's say, a resort, I think that is a given that as much as possible, metal would hold the longevity or the durability for the resort, for the resort. But I think the idea of having the wood element will not only add warmth, but actually would add, let's say, the I think a more conscious decision on applying that, since it won't oxidize or it won't rust due to the seawater exposure or to the air. Okay. So so you have your working properties, so it's easier to repair and maintain wood. So old wood can be retouched, can be added, like you can add if there is a chip or there is a defect or if there's a scratch or something, it's easier to to repair using, let's say, plaster or let's say wood glue or stain, so it's easy for maintenance wise. So if you want to change colors, it's easier as well. So you can just sand it and then reapply. For variation, so I think I mentioned earlier, there's a wide variety of wood, so you can stain it. Even so, in practice, we use let's say a base wood, or let's say lawaan as a base wood, and then you can stain it to any material or any color. So you can stain it to a mahogany red or a walnut color. So the variation, if as a designer, if there is an absence of the actual, let's say, expensive product like a Nara wood, you can have a more sustainable farmed wood, and then you can actually try to get the stain of the wood that you're aiming for. So wood has varieties applications, and there is a variety of tones or shades or colors for you to choose from. Okay. So for wood, so given it's from nature, so nature it alone is perfect, but we have your imperfections due to its natural state. So it has defects, it has properties that it might shrink, or there are a lot of factors that play when it comes to working with wood. That is not like metal or plastic, that it's very human, it's man-made. It's a human-made or man-made in productions and in factories. With wood, you it is what it is. It is a wood. So you have to consider that there's a lot of factors that play with wood. So for wood, since wood is a hygroscopic material, so it surrounds itself by vapors and moisture, and it loses moisture. It depends on the air. So that's why they have this term insight na mulihok ang kahoy. So well, yeah, it moves because of the nature na this is because of the nature of the material. So you also have your deterioration of wood. So you have your biological and abiological agents. So your biological agents, you have your decay, mold, bacteria, and insects. So these are very natural occurrence, especially when you're working with wood, especially when it's applied outdoors or exposed to a lot or a varying degree of weather exposure, air, and everything else. And then you have your abiotic, which includes the sun, wind, water, chemicals, and then your fire. So those are the possible. So your biotic, so well, woods are still organic, so any organic good, it has of nutritional value to plants, insects, and even fungus or something. So insects drill holes and drive lines into any wood. So this is very typical. That's why you have your termites. Even you have your carpenter bee that draw perfect holes in wood and everything in between. Okay. So you have your fungi and your moisture. So you have fungi drives feeds off of wood given in a favorable temperature. So you have your temperatures, you have 25 to 30 degrees for optimum growth of wood rotting fungi. So you can most of them would actually appear once the wood is exposed to the outside elements, since the fungi lives on moisture. And So if your moisture, so this is very typical in, let's say, plywood or wood that is not treated for outdoors. So any moisture that would hold, it would actually, like it's like gonna expand and then crack because it doesn't have the properties to withstand the moisture. So that's why you have this process of drying wood that would actually prevent the wood from cracking or the wood from peeling off. Right. So nutrients. So yeah. So nutrients. So you have your wood as an organic compound and it consists of 50% carbon. So it is basically a suitable nutrient for any fungus. So you have your insects. You have your wood boring insects, your beetles, your carpenter ants, and marine borers. So for wood classification, so based on our assignment that you have been assigned with different kinds of wood. So those you have your Philippine, your local, and then your imported wood. So we're gonna discuss briefly. So softwood is a coniferous or cone-bearing wood. So it's not necessarily softer than hardwood, but since some are much harder than the hardwood. So you have your pine, cedar, cypress fir, and redwood. So and then hardwood is broadleaf trees. So these dominant features presence of pores and vessels. So um, it shows variation in in shape and plates. Okay, so you can just run through this. So regarding the comparison charts of hardwood and softwood. So um, as you can see, these are more or less the important things to take note of is the density. So you have your density, the cost, and then the growth. So with softwoods, so these are easier to grow. Okay, so has their faster growth rate, and then you can see the fire resistance in both wood categories. So for hardwoods, it's more fire resistant, and compared to the softwood, which is less fire resistant. Okay. So these are the important properties that you have to consider when selecting wood. So you have to define the strength, whether it will be for construction or structural. Architecture, should it resist to weathering? If it's for interior, I think interior finishes, unless it's interior finishes shouldn't be a problem with regards to strength since it won't hold much structure or much load. So workability, if you want a hardwood or a softer wood, with regards to with regards to what use you have to consider again. So if would be for furniture or would it be for sculpture? So it you have to understand the use or the function before specifying. So you also have the drying properties and the bending qualities. So would you want your wood to be more flexible? Do you have a design that's more organic? Do you want the wood to work within that, let's say, design, and then you have your grain structure or pattern? Do you want the wood to seem to have like larger grain systems, or you want it to be more fine and more linear or repetitive? And then you have your finishing. So what kind of finish you want? A more natural finish, painted or veneer, and everything in between. So these are important properties to consider when designing, when selecting wood, and then, yeah, when selecting and specifying wood. Okay, so this is an example on how wood is applied in the wall panels, in your furniture, and then yeah. So you have your common term. So I won't be going in, since these are most likely like a glossary on which you can take into consideration or like to take into heart whenever we discuss on wood. So what kind of what are the kind of let's say, parts of the wood, or what is the anatomy of a wood. So there you go. So so please take note of these, since most likely these would go out to would appear in our exams. Okay. So I will be showing you so different, let's say, cuts of wood and how it would appear. So this is a plain saw wood. So this is at 30-degree angle. So between the face of the board and the wood's growth ring. So with the growth ring, you'll see these visible grain marks. So there you go. So if you want a design that's more visible with regards to the grain marks, then or grain, yeah, the grain or growth grain, so you can choose the plain saw wood. So for the quarter sawn wood, so it's more it has like in between a growth ring and a more linear, so it's a mix of both. So there, so it's very, yeah, it's more linear, it's vertical lines. And then you have your rift sawn, so it's also more finer, so it has a different degree as to the grain structure is shown. So you can see that's really linear, straight, and compact. So depending on the wood, so it would actually show this kind of pattern. And then also, so these are other common terms. So you have your book matching. So this is a veneer of wood. So they book matched it. So it's the same when you open a book, or siya mirror image. So you have your herringbone pattern as well. So this one is your slip matching. So it's basically one side and then repeated across. So you have this pattern at the developed. So this one is diamond matching. So you have this pattern um, reflected in let's say in a plane, so like this. And then your random matching. So it doesn't have a pattern. It doesn't have a designated pattern with regards to the grain structure. And then so you have your this one. So these are different applications. So this is a more similar. It has the same wood but applied in different patterns. So you have your rough lumber. So these are key points to consider. So S1S, S1E, S2S, so your surface on two sides. So S4S, surface on four sides. So these are your key numbers or keywords. Then so okay, so this is true in specifying wood. So nominal dimensions are approximate dimensions assigned to pieces of lumber. So and other materials as a convenience to the in reference to the piece. So dry lumber is deemed to have a moisture content of less than 19%. So with this, so you have your nominal size. So when you say 1 inch, what they really mean or the actual size is 3/4. So these are the actual measurements that um that you have to take note of, especially in specification, in cabinetry, and in cabinetry and in construction. So given that the wood would shrink or to reduce the moisture content. So yeah, so this is just a standard number that would they give out, but this is what it is in actual. Okay, so so you have your old growth and then you have your farmed wood. So what's the difference? So for old growth, so the old growth it's denser. So as you can see, there is a more compact grain structure compared to that of your 2x6 farm wood. So it has a more, let's say, wider intervals with regards to growth, since these are um fed. I think we have to consider it that it is farmed, so they have to be fed and fertilized for them to have, let's say, for them to come up with the wood that is acceptable to be, sold to the market. Okay. So given, so you have your, how much is, let's say, measured for you to get the board feet. So most lumber is measured and sold in board feet. So one board foot is equal to 14 cubic inches. So it is, well, calculated as follows. So we will have an activity around maybe Friday or next week regarding computation. So the unit of measure of wood quantity, so is equivalent to 12 inches by 12 inches. So ano siya? Okay. So this is 1 by 2. So it's one board foot equals to, so two, one board foot. So we'll have this computation as to the measurements. Okay. The measurements, yeah, computation of getting the board foot and, yeah, or getting the board foot. So wood specification and construction. So wood is still most used furniture material, and it's the most used material since historic, so pre 20th century. So wood has, like I mentioned, you have different applications of wood, and wood is, yeah, and it has different stages as to what application it is. So you have your marine plywood, your veneers, and then your solid wood. So you also have your hardboard, your particle board, and your composite board. Um, so marine plywood is basically sandwiching layers of wood glued together with different to varying degrees, 90 degree angle to create a more solid wood. And then you have your veneer. So it's more of a very thin sheet, which of very rare wood. So you can save less on wood, and then you can add it on a, let's say, an MDF material. And then you have your solid wood. So the good thing with solid wood is it can be refinished many times, whether it be scratch or damage. So you just um it it would just withstand a long period of time as long it is maintained properly. So and then you have your hardboard. So this is wood made of wood fiber. So you have your hardboard and particle board. These are the materials used when you are, let's say, specifying for cabinetry. And then you have your composite wood. So hopefully we have a more sustainable approach to the alternative materials. Okay. And then here, so when we're discussing with veneers, so you have your exterior veneers. You have your exposure one and your exposure two. So these are waterproof. So these are just basically what is applied to the veneer for them to be more suitable for outdoor exposures. And then you have this interior, so it's for interior applications only. So these are, this will just have a varying degree of application for glue. So for veneers as well, so you have varying grades as to the quality of material or the quality of the veneer. So wala siya, it doesn't have cracks, splits, or anything that is done to it. So you have your premium grade. So you have your N for premium grade. A, it's smooth and paintable. So um, it's a bit, well, not as, it doesn't have the premium quality compared to the N. And then you have your B, your solid surface. So you have, it has tight nods limited to one cross grains. And then you have your C, so improved veneer. So it has knot holes and bore holes. So there are particular measurements as to what is acceptable to be to be categorized into what grading. So you have your C, so tights and knots. So it has a varying inch, or 1 and 1/2 inch is permitted, and then you have D. So it is limited splits and stitching also permitted, but it's used to restrict to interior only. So it's not, so the premium it is, and more suitable it is for natural finish. The rest you can actually use other applications to improve the quality. So your wood specification. So these are the varying plywood specification. So you have your 3 ply, 4 ply, 5 ply, and then 6 ply. It depends on the application, and it depends on what is the thickness that you'll be requiring. Okay, so same for veneer. So you have different specification for wood. So you have your grade A, free of defects. B, so surfaces are patched and sanded, and C and D, so have defects, but the panels are still guaranteed to be well glued. So you have that as well. So there are a lot of plywood specifications to consider. You have your bamboo plywood, your hardwood veneer plywood, you have your OSB, or your oriented strand board, and then you have your MDF. So MDF is usually used in cabinetries, boxes, and anything that just needs, a stability of a line, or a straight dimensional stability. Okay. So as discussed, I think previously, so we already had wood joinery. So you have your edge joints, and then all the joints that is needed for construction. Okay, so this more so in furniture. Okay, so you have your biscuits, and then your TNG, your dovetail, and then your finger locks. Okay, so working with wood. Okay, so we're just gonna be discussing briefly. So, the wide variety of applications of wood. So you have this European beech. I think this is using the beech wood. This is, I think, bent. This one is a 3D veneer lamination. So, for you, it has like varying plies, or how many plies it has to create this form. And then you have this uh you have this tabletop. So it has this 3D veneer to sandwich, so it would seem lightweight and structurally sound. So for production or manufacturing, you have your machine. So you have your CNC, right, routers. So this for mass production. You have your laser wood. You have your profiling or molding. So this is your decorative and functional timber profiles, and then you're turning. So you use this is either with a CNC, or you have your manual nga lathe. So I think Sir Engineer Sungkad um will discuss you with this. Okay. So you have your forming. So laminations are composite, so made of thin layers of wood and rigid glue. So for plywood as a lamination, although its purpose is just to be flat and stable. So its constructional veneer plies are usually layered and alternate grain direction. So with 3D veneers, you can actually uh, bend it to suit certain forms, and for you guys to have uh, suited forms to go for the desired design direction, or the desired form or look. So you have your steam bending. So for furniture, you have your beech and ash, or your birch, and then your hickory. So these are wood that is easier to manipulate when it comes to bending. So you have your your Thonet bentwood chair, so everything. And then you have your formable surfacing. So you have your profile wrapping and membrane pressing. So it applies for veneers and melamines and other plastic foils. So you have your substrate, and then mura na ninyo siya i-gift wrap. you're just gonna wrap it around that substrate. Okay. All right. So you have next would be your manufacturing intervention and treatment of wood. So these will be just base chemicals as to what is applied in wood. So not everything is environmentally safe, or sometimes the chemical use is health hazardous or hazardous to your health. So you have so for wood, some species have natural decay resistant hardwood. So these are the species that you might consider. But for those materials that we don't have readily access of, there are a wide range of applications to improve the quality of the material. So you have your coating. So for coatings that would actually protect the wood for both indoor and outdoor in the environment. So it will prevent it from shrinking or swelling. So since these are the most common problems that would happen for a natural material like wood. Okay. And then you have drying. So for drying, so this is one of the most effective ways to prevent the degradation of wood. So for it to be thoroughly dry and kept dry. So okay. So we have two types of natural drying method. So you have your natural drying. So lumber is stripped pile on a slope on a solid foundation to allow air to circulate around. For this one, it would actually reduce the moisture content, and then it would actually, what's the name? It would actually, um, let's say, what do you call that? It would actually solidify, or it would actually make the wood more, um, wood not to be more susceptible to, let's say, natural degradation or defects, or kana para di ka siya i-attack o natural na mga natural exposures or something like that. And then you have your kiln drying. So kiln drying is done in a dry kiln where lumber is artificially dried to correct the moisture content. So it is used for more expensive lumber. So it for more refined uses sa wood. So it won't move anymore. So I think as discussed now, wood has the tendency to move. It depends if it's not properly dried. So kani you'll be this is would be very noticeable when you're using solid wood indoors, in flooring, and even in furniture. So if there is a misalignment, it means that the wood is has taken in additional content or has lost air moisture content. So treating wood with preservatives. So wood can be the decay of wood can be prevented with the use of wood preservatives. So hopefully with this chemicals, you have to select the most environmentally sound or most safe for anyone who will become in contact with the finishing. So you have your oil, and then you have your waterborne treatments. So the most typical ang kaning sa lignum. So this is widely used here in the Philippines. And then you have your remedial treatment. So these are for treatment of woods, a wood nga marag say tawag ani that would come in contact with mga outdoor elements or environmental na elements. And then next you have your fire retardants. So some wood were actually treated. So even if when you buy it and let's say in your local hardware, some of the wood are actually treated already. I think it's not as let's say checked or let's say required here in the Philippines, but I think there is a varying degree as to sa specifications if you want it, in interior application. Okay. And then on the last portion of your presentation, so you have your wood appendices. So kanina this is just a glossary of wood types. So with this one, you'll be able to see the type. what kind of wood, the characteristic, and then workability, finishing, and the uses, and then its weight if it's dried. So for the look, you can just search over over or search over the internet, or you Google it with regards how it would look, how it is applied. So I think for any wood, it's very versatile when it comes to applications. So there's also a variety on how it will be used structurally or in, yeah, finishes lang. So yeah, okay. I think that's it for wood material, for wood as a material. If you have questions, just ask ask me and Nathan in our Google Classroom. And then if you want, also you can also comment here in the video. Thank you.